Git. Maybe you've heard of it? Git is the behind-the-scenes systems that keeps track of a project's changes and allows for large-scale collaboration on something as delicate as code without chaos. Okay, without complete chaos. It's one of the few close to universal systems used by software developers everywhere, no matter their preference for language, IDE, or operating system. From the humble basements of small open source initiatives to the looming spires of those massive commercial tech stacks, Git unites us all. Okay, except for game developers. But I'm wondering why? Where are the other version control systems? What was so special about Git? And what was the world of software development like before it? I'll begin with a short history lesson. To illustrate what code collaboration was like before any kind of sophisticated version control, I don't need to time travel or be old. I can just remember what it was like to collaborate on coding assignments in university before being exposed to Git. Those were the days. There were lots of early version control systems that tried to solve this problem. Some were centralized, some were decentralized, some were open source, some were commercial, some were sort of hard to use, and some were pure misery. Developers would use different systems depending on their personal preference and the needs of a project. One developer in particular had a pretty big project he needed to coordinate. His name was Linus Torvalds. Linus was the inventor of Linux, one of the most ambitious collaborative projects in the history of programming. Linux was and is a completely free and open source operating system. Anyone can use it and, most importantly, contribute their improvements. After getting past the email me your code era of version control in the early 2000s, Linux development used a commercial system called Bitkeeper. But after some attempts to reverse engineer it, Bitkeeper wasn't so happy to be handing out free licenses to open source developers anymore. This put the project in a tight spot, because the decentralized, lightning-fast, and open source system it required to replace Bitkeeper simply did not exist. So what do? Well, if you're Linus Torvalds, you lock yourself in your basement for 2 weeks and build your own. In 2005, he sketched out a new system called Git, which could meet the project's needs. And so, Git was born. There was an immediate enthusiasm for Git, with people making tools to help support it and contributing their improvements directly, as is the open source way. So the moral of this story is that a coding genius just locked himself in his basement and cooked up a perfect universal version control system in a couple of weeks? And that's what we should aspire to be? No. Actually, by all accounts, Git was very confusing and hard to use. But Linus Torvalds did identify a few very important design decisions that might help explain why Git became so widely used today. There's this moment I can't forget from a tech talk. No, not a TED Talk nor a TikTok, but a tech talk which Linus Torvalds gave in 2007, 2 years after Git was officially released. Someone in the audience asks what is now sort of a hilarious question.
Do you know any companies that are using distributed systems internally?
So quite frankly, there aren't that many distributed systems.
It's wild to hear because a decade later, Git, a distributed or decentralized system, is essentially synonymous with version control. Everybody's using a distributed system internally because everybody's using Git. But at the time of this tech talk, that just wasn't the case. Most version control systems, including the one Google was using when Linus gave that talk, were centralized, meaning the code was stored in one location, like your boss's favorite laptop, or more usually a big server. And that location served as the ultimate, up-to-date version of the code. Makes sense, right? But this is not how Git works. Git is a decentralized system. You don't need a big server where everything is hosted. Instead, every developer has their own copy of the project on their computer, and those copies are synchronized back and forth, essentially by sending each other messages about what was changed. Although, just because there doesn't have to be a favorite laptop doesn't mean there can't be one. That's exactly what sites like GitHub are for. This flexibility meant that Git was able to win over the people who saw the merits of decentralization early, as well as the people who wanted a more centralized workflow. This brings me to my first big point. Git demonstrated how decentralized systems could be done right and work radically better than centralized ones. A lot of people didn't believe that distributed systems could be used effectively in companies with big code bases and rigid hierarchies, but Git disproved that. And this point helped pave the way for the ecosystems of decentralized technologies we have today. Ever heard of blockchain before? Majorly decentralized. And Mastodon and the Fediverse is essentially a decentralized social network. Decentralization wasn't the only interesting feature of Git. One of the most interesting and profound lessons I think we should keep in mind when developing technology is that the specifics of how something is implemented technically can shape the cultures and systems where this technology is used. Git is the perfect example to see this phenomenon in practice. Its technical implementation prioritizes speed and easy branching. This meant that developers no longer needed to perfect their code before a commit, since they're just committing to their own copy of the code, the branch. This had the cultural effect of encouraging more small commits with more descriptive messages, and made random experimental features way easier to play around with. Branches can also help reduce the cognitive load of working on such a massive project with your tiny human brain. You can just pay attention to the few branches you care about and ignore the rest. And that is such an essential idea when considering the massive, complex technologies that we've built over the past few decades. If Git's design hadn't prioritized speed for large projects or made it so easy to fork a repository, we might be living in a very different software landscape than the one we know today. How did Git transform software development? Well, it paved the way for decentralized technologies, encouraged a culture of experimentation and big projects, and its open source nature allowed it to grow and change with that culture, not against it. The part of this story that I actually find the most fascinating is none of those things. And it might not even be specific to Git at all. It's about how having a standard version control system enabled and encouraged a spirit of collaboration for code projects in general. See, Git allows any code project to become collaborative really easily. All you need to do is post your passion project on GitHub, and if there's a community of people who care about that thing, they can help you out with a simple git clone and a few commands. And this may be the biggest change any project can endure when it goes from a solo project to a collaborative one. I think it relates to a problem that I personally encountered a lot when I was self-studying programming. When you finish an Intro to Computer Science course in university or from JetBrains Academy, it's really unclear what actual use those skills have. Like, sure, I can make Game of Life, Mad Libs, and random maze solvers all day, but how do I actually make something useful, something I'm excited about, something others are excited about? Git. Git is the answer. If you git clone some project you think is cool, you can start making improvements with your beginner skills and actually get a feel for software development in practice without having to build your own thing from scratch. You can even just clone the repository of something sort of similar to what you wanted to build yourself and then adapt it to be the thing you wanted it to be. But of course, give proper credit where it's due. Building up your programming portfolio like this can help you get a job and deepen your practical knowledge, but other than just professional reasons, I also want to make the point that it can feel really good to contribute to something, to work together with other people in this pure collaborative way, all for the sake of building something together that none of you would have dared to attempt alone. If you're interested in picking up programming or advancing your skills, the lovely people of JetBrains Academy have made a ton of courses, many of which are completely free and open source, and we want as many people to know about them as possible. We've recently developed an Introduction to Git learning track where you can learn to use this very cool technology right in an IDE. You can also check out our practical guide to Git video where the technicalities of how it works in practice are explained with some nice animations. Thanks for watching this video. I'm Clara, and I'll be making videos about interesting concepts in computer science to inspire and supplement your learning as well as my own. That's all for this one. I hope you liked it, and good luck with your learning.